Welcome to HCR Basic Training Course Chapter 2.2. In this chapter, you will learn about setting robot before programming. Robot setting is very important process to use HCR in the right way. This course will take about 30 minutes and I want you to focus on this chapter. Let's start with turning on the robot. By clicking robot setting menu icon on the left side, you can see 7 subtitles. TCP setting is the first step of this chapter. Let's click the TCP setting menu. Before we start, I'd like to let you know about important concept of this setting. TCP is an abbreviation of Thule Center Point. Tool is any attachment placed on the tool flange of the robot, and tool flange is the part of the robot where tools are attached. Tool center point is the part of the tool that is in contact with the workpiece. Tool can has its own axis and we can modify and also use when programming robot. In this screen, you need 4 kinds of important data about our tool to make a new TCP. You have to know the position data of TCP and center of gravity from the flange, and also weight and orientation of the tool. To make a new TCP, click Add icon and type the name of your tool. After clicking the button, data fields of this screen are activated and you can type all data if you know the precisely. Let's fill in some of data field like me. Click the checkbox of the screen to use center of gravity. If you do not use center of gravity of your tool, unexpected collision detection or some kinds of safety errors may occur. Please check the datasheet or modeling file and find the center of gravity data, and then fill in this field. After filling in the data filed, Roadie automatically calculates the length of your tool and in scale. You need to fill in the weight data of your tool also. And then, you can click the Save button to save all and finish this step. There is a drop box in the screen and you can see all of your TCP lists if you click the drop box. If you want to use other tool in that list, select the tool and click Activation button at right corner. Let's go back to the operation screen and check the operation setting. As you can see in the screen, payload is applied according to your TCP setting. Let's go back to the TCP settings screen and click the Edit button. Roadie offers TCP calculator for users who does not know the position data. Let's click the position calculation button on the screen. By using the manual control mode, you can calculate the position of TCP. To calculate the position of TCP accurately, receive the position data from various angles with respect to on point and analyze them. You need to set fixed actual point to calculate. After moving a tool to face a certain point at P1, enter the position data. After that, move to an arbitrary point, P2, and let it face the same point and enter the position data. Proceed this way until you have at least 3 points. To start the calculation, please click the Start button, and then you can make a P1. If you click P1 icon on the screen, you will see manual control mode screen. Move your robot by using manual jog or input or direct teaching. After your TCP reaches at the fixed point, click the OK button and go to the next step. Click P2 and P3 icon on the screen and repeat this process. The important thing in this step is that the angle difference between each point should be at least 10 and TCP should be reached at the same fixed point in each process. You can make more points for TCP calculation and you can get more precise data if you make more points. After you make third position, you can see the calculation button is activated. Click the calculation button and check the answer of Rody. Now you got the TCP position and tool length data. If you are satisfied the answer, click the apply button to save the calculated data. If your tool has tilted angle from original TCP axis and you need to use tilted tool axis when programming, you can also calculate the orientation of your tool. Let's click the orientation calculation icon on the screen. There is a guide image for calculation of tool axis in PIC.2. You have to align the orientation of 3 axis of the tool to the orientation of robot base's axis. Refer to the guide image. Click the calculation icon and use manual control mode for this process. After alignment, click OK button and you can see the calculated orientation of your tool. If you satisfied, click the apply and save button to finish this step. Finally, click the activation button to activate this modified TCP setting to your robot. In the manual control mode screen, you can see your TCP and tools axis on 3D simulation screen. The yellow sphere on the screen is TCP of your tool and you can check your tool axis and also move your robot refer to that axis. At last, you can make and modify your TCP setting for programming. Let's go to the next main step of this chapter. The next is I/O setting. In this I/O setup screen, you can see 4 tabs and you can change the screen by clicking the tab menu. Also, there are buttons for pages in each tab. Just click the icon if you want to see the specified page. In digital input and output section, you can see 3 types of images and you can see the reference list at the bottom line of the page. If you click the edit icon for each input and output signal, you can change the name and assign one of preset functions for each port. You can assign 4 types of command as you want. Choose command type and signal level. click OK to save the setting for that input signal. You can also assign commands for tool input signals, but you cannot assign the command for redundant input signals. You can also assign two command types for digital output signals. This will help you to monitor the robot status through the other equipment like PLC. In analog signal taps, you can change the name of each signal, and that will prevent confusing one and other signals when you program the robot. After the all assignment and modifying is done, click Apply button to save all change and apply this setting to your robot. The next step is coordinates. You can manage your own coordinate system. There are 3 types of coordinate, and you can make a new one and also delete. In this setting, you can make new coordinate system. And you can use your customized coordinate system for robot programming. This will let you handle your robot more easier. Before we start making a new coordinate, make virtual TCP like this screen for your convenience. This TCP is only for setting your customized coordinates. Type exactly same position and orientation data for your virtual TCP and save and activate. Now you are ready to start this step. Let's make point type first. You can use this type of coordinate when you want to rotate the axis or apply offset values in simple way. Click the point icon to add a new coordinate. You can see a new coordinate in the list and change the name of the coordinate. To make point type coordinate, you just need only one specific point, and you can make by clicking the Set button of the screen. On the 3D screen, you can see the virtual TCP for coordinate function. Tool axis is exactly same as base axis. In point coordinate case, the position of TCP will be the new origin and the tool axis will be the axis of the point coordinate. Let's type 0 for X and Y and Z position and click the Move button. This time, your virtual TCP is exactly same as base origin and there is no angle offset from base axis. Let's click the rotation button for Z axis and rotate your TCP. Now, let's make an offset by moving the TCP from 0, 0, 0 to 100, 100, 0, and rotate 45 degree in Z direction. You can also rotate in other directions. If you click the OK button after moving the robot like me, a new origin and axis will be applied in accordance with your TCP position. The origin of this coordinate point has 100 mm offset from the base origin in positive X and Y direction, and also has rotated axis with 45-degree offset. You can see this new origin and axis in 3D simulation screen. And detailed data of this coordinate is displayed at the bottom of the screen. If you press the Move button, you can move your TCP to the new origin of this coordinate. Click Apply button to save all data and apply this coordinate to your robot. The next type is Line Type Coordinate. You can use your real TCP instead of virtual TCP. You usually use this type when you need to use a specific axis to move your robots like conveyor tracking or special patterns. Let's click the line icon to add a line type coordinate and change the name of this coordinate line. You need 2 waypoints to make a line type coordinate. Click Set button to make a first waypoint of this line. This point will be origin of this line type coordinate. Move your robot as you want and click OK button to save the waypoint. Let's make the other waypoint to make a straight line. Click the Set button of the second point section and move your robot as you want. After you click the OK button at this time, you can see your new y-axis on the screen in blue color. Black sphere is the origin of this coordinate and positive direction of y-axis is as same as direction from first to second waypoint. In this line type coordinate, it's hard to get precise x and y axis as you want, so I recommend you to use this type when you need a specific direction. I usually use this line type coordinate for manual control mode, not for modifying the move commands to copy and paste. If you want to check the real position of your waypoints, just press the Move button on the screen. You can see the position data of your new origin based on base coordinates origin. Click the Apply button to save this new coordinate. The last one of this coordinate function is Plane Type Coordinate. If you can use this type of coordinate when you program, you can copy a random but specific workspace from the original position to anywhere you want. This is very powerful and also useful function to copy same automation process even if you don't know the exact position and rotation angle data of your workspace based on the base origin of robot arm. Let's click the plane icon to start. You need 3 waypoints to make a plane type coordinate. Click the Set button of first waypoint section. This point will be a new origin of this plane type coordinate. Move your robot as you want and click the OK button to save the position. Click the Set button of second waypoint section. After you move your robot and click the OK button. After you click the OK button at this time, you can see your new y-axis on 3D screen. Black sphere is the origin of this coordinate and positive direction of y-axis is as same as direction from first to second waypoint. Let's click the Set button of Thread Waypoint and move your robot as you want. After you click the OK button of the screen, you can see your customized plain and blue color. Let's imagine virtual circular arc with arrow counterclockwise, which includes 3 waypoints by turns. Make a similar arc with your right hand finger. At this time, the direction of your finger must be same as the direction of the arrow of virtual arc. And then, put your thumb up. The direction your thumb indicates is positive z-axis of this plane type coordinate. Because of this z-axis, sequence of making 3 waypoints is very important. And as you can see on the 3D simulation screen, the color of each waypoint is same as the color of data section. After making the plane coordinate, please check the origin and rotation angle data of your robot and click OK button to save this coordinate. If you press the Move button of each coordinate, you can move your TCP to the origin of each coordinate. If you click the use icon of each waypoint and activate them, you can use this waypoint as an origin of coordinate for programming or manual control. In that case, I recommend you to change the name of the waypoint to remember easily. If you want to delete your coordinate, choose the coordinate as you want and click the trash can icon on the screen. Let's go to next step. If you click the global variable menu, you can see a blank screen for the first time. If you want to use a global variable, click the Add button and change the name and initial value of new global variable. You can use global variables when you need to share variables for multiple robot programs. Global variable is not refreshed saved even if robot system restarts or shuts down. So, if you want to change the value of this global variable, click the edit icon manually and change the values again. Let's go to the final step. Click the IO-bit operation menu. In this screen, you can make a trigger for preset command with combination of input signals. You need to set the combinations of general input values. If you want to add operation, click Add first. If you click the IO icon, the value will be changed from high to disabled. Blue color indicates high value, red indicates low, gray color means disabled. If setting is disabled, the value of that input gate will be ignored when calculate the total combination value. After setting combination of input values, click Function drop-down box and choose one of the list and check the value. Click Apply button if you want to apply this setting. Let's go back to the robot operation screen. In this screen, you can see your global variable and its value on the Monitoring tab. Click the Management menu and click the Setting Management title. In this screen, you can manage your robot setting values in a file format. If you make a file for your current robot setting with customized name and save it in the hard disk drive. Click the file name field and type as you want, and then click Export button to make a new setting file. After that, we can see the brand new file in the file list. You can delete selected file and also copy the setting value from the imported file. Let's click the Import button to apply setting values from a selected setting file. If you click the Import button, you can see a pop-up menu and select individual setting values as you want by clicking each icons. After clicking each icon on the screen, selected icons will have a different color. Let's select icons as you want and click OK button to apply selected setting values to your robot. Great job and thank you for your effort to this chapter. Now you are almost ready to start robot programming. The only step left is safety setting just before the robot programming. Thanks for concentration and see you next step.